Okay, so when we left a couple Thursdays ago, we left and we were talking about how to do conversions. And the conversions that we were doing, you can find them on page 311 if you flip there now. In each one of those, we were converting moles to particles. Moles to particle conversions. All right, that's the title we'll give to that type of problem. Now, we're going to have different types of problems in this chapter. Technically, there'll be about 6 different types. But the more you do, the easier it becomes. It will actually become like second nature to you. We will have something designed a little later down the line called a mole map, which will also help you get even faster. But for now, we're going to think through how these work. Now, the mole was a term that represented a number. Okay, does anybody remember what that number was?
6.02 times 10 to the 20.
There you go. 6.02 times 10 to the 23rd. What do we call that number? Yes, Avogadro's number. I'll write it out just so we get familiar with it. The more times you write it, the better you will know it. All right, so it looks like that. It's a huge number. It's a huge number because when we count things in chemistry, we count a lot of really tiny, small little things. Okay? Now, what we did on that Thursday was we were converting from those moles to actual numbers of little tiny particles. Okay? So let me give you a sample characteristic of those problems we did. 3.31 moles of C2H6. Your job was to, and is to right now, is to convert this into a number of representative particles. Does anybody remember what the types of representative particles were? Well, look at the bottom of page 310 right now. There's a nice picture. It takes up half the page. What are the 3 types of particles called? It's right there. Molecule, atom, and formula units. Those are the 3 possibilities we have. Now, what we need to do is scan this compound right here, C2H6, and based on its formula, determine which one is it for this compound. C2H6, is it a molecule, is it an atom, or is it a formula unit? What do you think, and why? I heard formula unit. Why would it be formula unit? It is a compound. Does it limit that to formula unit only, though? No. It also could be a molecule. So how are we going to know whether this should be a formula unit or a molecule? What comes first in a formula unit? In the formula? Metal. Remember, metals, ionic compounds, formula units. Does a metal come first in C2H6? No, which makes the smallest particle of it a molecule. Okay, now the way we played this game here is dimensional analysis. We put a time sign, we put a division line. What we have always goes underneath the line. What do we have right now? Moles of C2H6, right? What do we want? Molecules, exactly. Molecules of C2H6. Now, unfortunately, we don't have an abbreviation for molecules because we already abbreviate mole as MOL. So we just got to write that out. Now, the question is, what is the relationship between moles of anything and molecules? 1 to Avogadro's number. Absolutely. Just like if I said, what's the relationship between a dozen and a number? What would you tell me? 12 to 1. 1 dozen equals 12 donuts. Okay? And here, 1 mole equals Avogadro's number of particles. We're going to be using this number a lot. So get used to writing it. All right, so right now we have 3.31 moles times Avogadro's number over 1. Now, what can we do at this point right here? If you like to get things out of the way early, We can cross cancel like units that are on the top and on the bottom. Get rid of those, and it cleans things up a bit. Now we have 3.31 times Avogadro's number. Now for this, remember, use those parentheses on your calculator, and it's going to help your calculator understand what you want it to do. If you don't have them in place, your calculator might misinterpret what you're trying to get it to do, and you're going to wind up with a way wrong answer. Now, right now, my calculator says 1.99262 E24. Now, if your calculator says E24 as well, E24 just means times 10 to the 24th power. That's what it means. Okay? Pardon? Because I'm multiplying 3 times 6 times 10 to the 23rd power. So that means it's going to go up by another factor of 10, which means going up from 23 to 24. Okay? Now, would I leave this on my paper as an answer? No. I got some cleaning up to do with it. First of all, I must look at and note how many sig figs are in the initial measurement. How many are here? 3. That means I got to report 3 in my answer. So it goes from 1.99262 to 1.99. Because a 2 follows the 9, I need to round down. Then comes the times sign, and then 10 to the 24th. Can I circle this and be done? Yes? I say no. Why no? Unit. You got to have a unit on the end of these. So the unit is molecules of C2H6. Now you have a good final answer. You can circle it when you're done. Alright, so that was a moles to particle conversion. On your calculator, or where did it put it? It went 19 times something? Did it have times 10 to the 24th at the end? Okay, that's weird. Bring it up to me later and we'll kind of try to figure out what's going on with that. Because remember, scientific notation always has a number between 1 and 9 as the first digit followed by a decimal point. You can't have like a 2-digit number in front of the decimal point. It's not allowed. Okay, try one more for me. You do right now, let's say 5.8 moles of NaCl. I want you to figure out right now how many particles this is. Okay? And you can use what we have in the previous problem to help you. Because the numbers above and below the line are going to be the same. Okay? The only thing that's going to be different is one of the units. So underneath the line here, we have 1 mole NaCl. Above the line, we just said Avogadro's number will stay there. So your challenge here is to figure out, first of all, what is the little particle of sodium chloride called? Is it a molecule, an atom, or a formula unit? Formula unit, right. What gave it away? What's that? Besides being in the book. Starts with a metal, yep, or an ion, yeah, absolutely. So that means it's formula units. So at this point here, you cross off your like units, we multiply, and we'll get our answer.
How do you put the power to 3?
On your calculator? Each calculator is a little bit different, but do you have a 10 to the x printed on your calculator anywhere? Nowhere, even above a button? Do you have parentheses? Okay. Why don't you bring that up once we're through today, and I'll help you try to find it. Because there's so many different brands of calculators. Each one kind of works in its own way. Like my calculator here, if you look at this, I have this up arrow button right there, and that's how I go to a new power. So I do like this. I go 6.02 times 10 up arrow 23.
I have the arrow.
You do? So that may help you figure this out. And like I said, if you don't get it by the end of today, just bring it up. All right, so we got 5.8 times that answer. How many sig figs will we report in this thing?
2.
2. What will they be?
3 point, and I don't know if you round it up to 5 or not.
Yeah, you would. Because the digit following the 4 is a 9, it's going to be 3.5 times 10 to the 24th. All right, and remember we can substitute the letters F and U, and then we follow it by the chemical formula. Okay? All right, so that is a mole to particle conversion. Well, what if you see the opposite? What if it says, what if it gives you particles, and let's call this particle to mole conversion. We'll title these so later you can go back and when you get a problem you'll be like, oh yeah, I got a particle to mole conversion problem right in my notes. So I can use that as a model. And if you flip the page over to page 312, look at 4A. We have 5.75 times 10 to the 24th atoms of aluminum. And we are to find moles. So what that means is we got to set up a problem that's going to look like what we've been doing before, but what we find above and below the line is going to be a little bit different now. What do you think I should put below the line? Just unit first. What unit should I put down there? Atoms of aluminum. Right. And you're actually correct about putting Avogadro's number there. That's what I was going to ask next. So what we have is atoms. What do we want in this problem? Mole. So I'm going to put MOL, AL on top, moles of aluminum.